Number 7, taken from the PastPaper C2 January 2008. It's an integration question. In figure 2, the curve C has equation y equals 6x minus x squared, and the line L has equation y equals 2x. Show that the curve intersects the x-axis at x equals 0 and x equals 6. A way of thinking for this part is, if you're going to find the point of intersection of the curve with the x-axis, it means that you have to find the roots of this curve. So in order for you to find the roots, you first need to factorize. So 6x minus x squared, x is common, you take x outside and you open brackets. 6x divided by x is 6, minus x squared divided by x is x. Then you say that the y is equal to 0, which is the x-intercept. Therefore, either x is 0 or x is equal to 6. Part B, show that the line L intersects the curve C at the points 0, 0 and 4, 8. So when two graphs meet, either a line or a curve and a curve, or a curve and a curve, you have to use the method of y equals y. So you take the equation of the curve and make it equal to the equation of the line, which we did here, and then we solve for x. X on one side, we take everything to one side, so it becomes an equation equals to 0, a quadratic equation equals to 0. Therefore, we factorize and we solve for x. X is either 0 or 4. Now, when x is 0, you replace it in the equation, one of the equations, and you get y equals 0. And when x is 4, you replace 4 in either equations, either this one or the curve or the line, and you will get the answer for y, and it's going to be equal to 8. Part C, the region R bounded by the curve C and the line L is shown shaded in figure 2. Use calculus to find the area of R. So when they say use calculus to find the area R, it means that you have to integrate, use integration to find the area, the shaded area. Method 1, you integrate the curve, equation of the curve, minus equation of the line. So equation of the curve, yc minus yl dx, and the bound here it's 0 and the x of the points of intersection here, which has x4. So 0, 4. So this is equal, integrating from 0 to 4. You have the y, or the equation of the curve, 6x minus x squared, minus the equation of the line is 2x dx. Now we collect, this is equal to 6x minus 2x is 4x, minus x squared dx. Now we integrate, it's 4x squared over 2 minus x cubed over 3, and the bound is 0, 4. Now we replace 4 instead of x. Now we simplify 4 by 2, it's 2, so let's write it as 2 here, minus 4 cubed over 3. So this is equal to 2 times 16 minus 64 over 3. Common denominator, so here it's 1. Common denominator, it's 9. 3 times 2 times 16 is 96 minus 64 over 3, which is equal to 32 over 3. So this is the area of the shaded region. Now method 2 is you take the region which is under the curve that I'm shading now, and you integrate using the equation of the curve bounded between 0 and 4. So you will be finding the area which I'm shading now in purple. After that, you subtract the area of the triangle, which is this one, and once you subtract this area of the triangle, you will find directly the area of the shaded region. So we integrate first the y, or the equation of the curve, and we take the bounds 0, 4, and we replace, after we integrate, we replace it, we get 80 over 3. And then finding the area of the triangle, it's 0, 4 is the height, multiplied by the length of the base, which is here representing the y of this point, which is 8 found previously. So 8 times 4 is going to be 32, divided by 2 is 16. Therefore you subtract 80 over 3 minus 16, and you get 32 over 3, which is the area of the shaded region R.